Hi everyone, welcome to lesson 4. I'm actually using the same PowerPoint as the previous lesson, so I have the PowerPoint for lessons 3, 4, and 5 all together. And we're now going to do lesson 4, which is on adding and subtracting real numbers. All right, so let's start this slideshow. We're going to learn different rules about how to add with negatives. That's really the main focus here. Okay, so you can use a number line. That's kind of the first thing to know. As you're keeping track of all the different rules we're going to see, just remember that the number line method is available to you. It's not always the fastest way to do it, but it can help if you know that you're bound to get mixed up with the rules that we'll learn. So I'll just do these first 4 problems using the number line, and then we'll talk about the actual rules for how to add numbers with positives, negatives, or a combination. So for the first one, -2 plus 5, you can start at -2, and then plus 5 means you're going to the right. So 1, 2, 3, 4, 5, and we land at the answer, which is 3, positive 3. Okay, so the first number is where you can start. If you're adding a positive, you can go to the right on the number line in that positive direction. Okay, so just notice that, the first 2 that we added, we kind of crossed over the 0, and then we had 3 more to go to make 5 altogether. All right, let's do the same thing with number 2. I'll use a different color here. 4 plus -6. Now I'll start at 4. But if I'm adding -6, that's really the same thing as subtracting 6. This is the same thing as 4 minus 6. We'll talk about that. So with subtraction, what you'll be told in a little bit is anytime you subtract, you could also approach it with adding the opposite. Okay, so 4 plus -6. I would start at 4 on the number line, and then I would go 6 to the left. 1, 2, 3, 4, and now I'm at 0, 5, 6, and I've ended up back at -2. So notice that my answer was negative for that one. So the problems we've seen so far, -2 plus 5, we got positive 3. 4 plus -6, we got -2. Okay, good. Now our next example, number 3, -1 plus -3. I'll just make some room on the number line here. So -1 plus -3. Let's start at -1, which is just one space to the left of 0. This time when I add -3, I am going to go to the left, 1, 2, 3. So I end up at -4. Okay, so once again, adding a negative is really the same thing as just subtracting. Okay, so -1 plus -3 is the same thing as -1 minus 3. All right, one more example to do on the number line, and then we'll eventually get to the rules for how to do this without using a number line every time. -5 plus 5. So we'll start at -5, and then we will plus 5. We will add 5, which means we'll go 5 to the right. 1, 2, 3, 4, 5, and we land at 0. So -5 plus 5 is 0. These numbers are called opposites or additive inverses. So that's the next little vocab question for you right below. Or definition along with some questions. Any 2 numbers whose sum is 0, which is what we just saw, those numbers are additive inverses or opposites of each other. So it's essentially the same number, but with opposite signs, one positive, one negative. So for example, the opposite of -2/3 would be positive 2/3. The opposite of 5.4 would be -5.4. So that's all there is to the idea of opposites. So you're just taking the opposite sign or changing the sign from positive to negative. And again, anytime you add opposites, their sum or their answer to that addition problem would be 0. They kind of cancel each other out. All right, so that was a little introduction of adding with different signed numbers. We're going to do that some more here, but we're going to start to notice some patterns and pay attention to some rules here. So these first 4 examples, we are adding signed numbers that have the same sign. So what we mean by that is that we're adding a positive plus a positive or a negative plus a negative. So that's what we mean by same sign. So either both positive or both negative. That's what we're seeing in this little set here. So what we're going to do when we add numbers with the same sign is we will add the absolute values and keep the common sign. What does that mean? Okay, so adding the absolute values. Essentially, if you remember, absolute value is distance from 0. So absolute value is always positive. So I take that first sentence to mean pretend each number is positive and add them, then keep the common sign. So if they're both negatives, keep the negative sign. If they're both positives, keep it positive. But the point is, when your numbers have the same sign, we are adding. Okay, so number 1, -2 plus -4. If we follow the step that's given to us, the absolute value of -2 would be 2. The absolute value of -4 would be 4. 2 plus 4, I'm going to get 6, but the common sign is, negative. So our answer will be -6. And for the life of me, I can't, I feel like I can't figure out a way to teach this concept without making it sound harder than it is. So I shall do my best, but I have a tendency to over-explain, so I will try not to. To repeat this problem, -2 plus -4 is -6. Notice that 2 plus 4 is 6. The common sign is that negative sign. In other words, these numbers have the same sign. We add them and keep the same sign. So I'm keeping that negative. Okay, that was number 1. Number 2, I had to keep it in here just for comparison, but 2 plus 4 is 6. Not really much to say about that one other than just reminding you, a positive plus a positive, still positive. Okay, so I'm still doing the same process, adding and keeping the same sign. Number 3 and 4 are going to be a little more challenging because they do involve fractions and decimals, but we know how to deal with those. So let's look at number 3, -1/5 plus -1/4. Okay, so remember, to add fractions, we need a common sign. We need a common denominator. Sorry about that. Common denominator. So -1/5 plus -1/4. I need a common denominator. The denominators are 5 and 4. So one possibility is to just multiply those together. 5 times 4 is 20. So I'm going to rewrite the fractions with a denominator of 20. And then if I'm changing the denominator, I have to change the numerator in a similar way. So with this first fraction, I'm going to do 5 times 4 to get 20 for the denominator, and then 1 times 4 to get 4 for the numerator. So 4/20ths, and I am keeping that negative sign as well. So -1/5 just got rewritten as -4/20ths. We'll do a similar process for the -1/4. 4 times 5 is 20, so 1 times 5 is 5. Okay, and notice the parentheses. A lot of times we put parentheses around negatives just purely for sort of a visual symbol to help us keep track of the numbers that we have. They're not really necessary, but you'll see them a lot, especially when there's multiple negative numbers in a problem. The second or third negative number often has parentheses around it. Okay, so when we've rewritten our problem, -4/20ths plus -5/20ths, now we get to add, because we finally have the common denominator of 20, and now we can add the numerators. -4 plus -5, that will be -9. So our final answer is -9/20ths. And I want you to notice how I've rewritten it. I almost can't help but put the negative sign in the numerator. When we type these answers, you'll often see the negative sort of off to the side of the fraction. So negative and then the fraction 9/20ths. I've written it as -9 in the numerator over 20. Either one is fine. They're both okay. As long as the negative is somewhere in the answer, either one of those answers is fine. All right, so the point there was a negative plus a negative is equal to a negative. We added and kept the common sign. The real work there was just remembering how to add fractions, right? That was maybe still the hardest part about that one. All right, number 4, -3.6 plus -5.1. We're adding two negatives, negative plus negative. We'll keep the common sign. So our answer will be negative. what I'm doing right now is lining up my decimals. I'm going to add the absolute values, right? So I'm adding them as if they're positive, 3.6 plus 5.1. I'm adding those together, 6 plus 1 is 7. Keep the decimal points in line. 3 plus 5 is 8. So I've just added and gotten 8.7, but I'm keeping that common sign. So really, my final answer is negative 8.7. So each of these problems shows that when you have two numbers with the same sign, you add and keep the common sign. So negative plus negative, still negative. Positive plus positive, still positive. It's possible at this point you might be thinking about or remembering something about, wait, doesn't two negatives equal a positive? Why am I not hearing that? Negative times negative is positive. So that might be kind of rattling around in your mind right now. When we learn about multiplication and division, we will see that rule, negative times negative or negative divided by negative is positive. That can cause some confusion when we're doing adding and subtracting. So keep in mind the number line, right? A negative plus a negative, you're just moving further and further to the left on that number line. You'll get more and more negative. Okay, so always come back to the number line with adding and subtracting if you know you're getting mixed up with this. All right, let's move on to the next slide. Now we're going to see some examples where we are adding numbers that have different signs or opposite signs. Now, instead of adding, we really will treat these as subtraction. So we'll just read our little summary here. If numbers have different or opposite signs, we will subtract the absolute values. And in parentheses, I have larger minus smaller. So we'll take the bigger number minus the smaller number. Then keep the sign of the, quote, bigger number. And what we mean by bigger number, it's the one with the larger absolute value. Here's number 1, 9 plus negative 12. Okay, 12 is bigger than 9. So I will consider that a bigger number. Okay, 12 is the bigger number here. So the bigger number is negative, which means my answer will be negative. What am I going to do? Okay, let's subtract the absolute value. So what I'm doing in my head here or writing out is I'm actually doing 12 minus 9, which is 3. But I'm keeping the sign of the bigger number, which is negative. So my answer is actually negative 3. So 9 plus negative 12 is equal to negative 3. Feel free to sketch a number line, okay? Just to give yourself a little guideline of what this would look like. So I just sketched a little number line with 0 in the middle. I'm just putting a 9 off to the right here. And now I'm imagining that I would go negative 12. I would go 12 units to the left in that negative direction. The first 9 would get me to 0. And then how many more would I have? I'd have 3 more to go. 1, 2, 3. That would give me, oops, that would make me end up here at negative 3. Sorry, that's really messy. Okay, but still get the main idea. Let me attempt that one more time. Okay, so anyway, we want to be able to do this without drawing a number line every time, of course, but you can always still come back to that if you need to. 1, 2, 3, negative 3. Okay, so once again, 9 plus negative 12 is negative 3. Start at 9 on the number line and count to the left 12 spaces. The first 9 spaces will get you to 0 and then 3 more. It's just a reminder that you're landing in that negative zone there. Okay, good. See, I told you I'd over-explain. Okay, number 2, negative 6 plus 8. These numbers have different signs, so I will subtract. 8 minus 6 is 2. So what's my answer? Is it 2 or negative 2? Well, negative 6 plus 8. 8 is the bigger number. The bigger number is positive, so I will keep the sign of the bigger number. So my answer will be positive. Once again, if you sketch it out on the number line, here's 0. If I start over at negative 6, and then I count up 8 spaces, the first 6 spaces would get me to 0, and then 1, 2 more, then I'd land at positive 2. So you can kind of visualize that to help remind you about the sign of your final answer. Okay, and believe it or not, we can still use that same approach of using the number line, even with fractions and decimals. So for number 3, negative 7.5 plus 2.3. I'm not going to make an elaborate number line here with decimals, but I can at least understand that, okay, if I'm over here at negative 7.5, somewhere between negative 7 and negative 8, if I add 2.3, 1, 2, plus a little more, I'm somewhere here between negative 7.5 and 0. I haven't passed over 0, so I am still going to be in that negative area of the number line. So that's just sort of a visual clue about I should be getting a negative answer, which fits with the rules, okay? So we should subtract the absolute values, 7.5 minus 2.3. And yes, those signs look different from the original problem. Remember, we're dealing with just the absolute values. So I'm treating this as 7.5, I'm treating this as 2.3. Because the signs are different, I'm subtracting. 5 minus 3 is 2, bring down the decimal, 7 minus 2 is 5. So when I subtract, I'm getting 5.2, but based on my little number line sketch here, and based on the fact that the bigger number is negative, I know my answer should be negative. So my answer here is negative 5.2. So we should be able to do these just based on the rules. If the numbers have different signs, subtract and keep the sign of the bigger number. The bigger number was 7.5. That one had a negative sign, which is why my answer was negative. Now please notice how I subtracted the decimals. Here's what not to do. The order is really important, okay? So make sure when you're subtracting that you put the bigger number first. So if I wrote it out like this, 2.3 minus 7.5, that's not going to give you an answer that makes any sense. You might start subtracting and then you'll find yourself borrowing in a way where you're kind of stuck. So no, don't do that. Definitely make sure the bigger number is written first and then the smaller number as you're subtracting. All right, we've made it to number 4. This is a fraction problem. 4/7 plus negative 3/5. It is hard to tell which of these is bigger or smaller because the denominators are not the same. But we do know that the signs are different, so we know we will be subtracting and then keeping the sign of the bigger number. So let's just worry about either adding or subtracting. We're going to need a common denominator either way. So let's do 7 times 5 and get our common denominator of 35. Oops, go back. So our LCD, or common denominator, 7 times 5, 35. So I'm working on building up those fractions right now. For the 4/7, I multiplied by 5 over 5. So I can rewrite that as 20 over 35 plus. For the negative 3/5, if I multiply that by 7 over 7, right, because 5 times 7 is 35, I'm getting 35 for my denominator, and then 3 times 7 is 21, so I'll get 21 in the numerator. And that one was negative. So take a look at how we've rewritten it. Here's what you should have: 20 over 35 plus negative 21 over 35. Now that we have common denominators, now we can tell which one is the bigger one, which one is the bigger number. And these are so close to each other, right? So we have 20 and negative 21 as the numerators. 21 would be considered bigger, has a bigger absolute value. So we will keep the sign of the bigger number, which is negative. We will keep the common denominator of 35, and now all we have to do is subtract the numerators. So 21 minus 20 would be 1. So my answer will be negative 1 over 35. Notice how I wrote the negative sign off to the left of the fraction. I could also write it in the numerator if I wanted to, negative 1 over 35, like that. As long as the negative is there somewhere. And if you're just listening and not able to see, you're not even hearing the difference there. So that's okay. As long as the negative is somewhere in the fraction, either off to the side or in the numerator. And then we have a 1 over 35. Okay, so with all those problems, we had numbers with different signs. We subtracted the absolute values, the bigger number minus the smaller number. And then whatever answer we got, we applied the sign of the bigger number. So we keep the sign of the bigger number. All right, adding and subtracting. Okay, so what we're gonna see now is some more examples related to subtracting. These problems are gonna get just a little bit longer. Okay. So it feels like we were just talking about subtraction, actually. I guess technically that was still adding, right? The thing is, adding and subtracting, it's all connected, okay? So what we're about to see next is we're going to see some problems that start out as subtraction problems, but we will rewrite them as addition problems. Okay, so you can see the rule up here written in orange. So what it says is A minus B equals A plus negative B. So the sentence that describes what that is to subtract B from A, add the opposite of B to A. In other words, when you subtract, what you can do is add the opposite. Okay, so that's sort of the key phrase here, add the opposite. All right, and remember, opposite just means changing the sign. Okay, you do not have to show your work in the way I'm about to show you right now. This is a topic where some of you are finding this way too easy, and some of you are already confused and worried about getting mixed up with all the sign rules. So either of those places is fine for a place to be, but if you know you're going to get mixed up with these rules, I would encourage you to follow this process a little more strictly because it will help prevent some mistakes. Let me show you what it looks like. So here's our first example, -5 minus 7. What we can do is rewrite this as -5 plus -7. Those two expressions are the same, okay? So if you need a little phrase to go with it, keep, change, change is one way to phrase what we're doing. We're keeping the first number, that's kind of like A. We're changing subtraction to addition, but then we're also taking the opposite of the second number. That's what add the opposite means. It's kind of like keep, change, flip, where you're multiplying by the reciprocal with fractions. This is adding the opposite. So you're changing an operation and then you're taking a kind of opposite of your second number. By doing this, then it's like we're back where we started with addition. Now I can use the rules that we just learned, right? So -5 plus -7, oh, now I can see they have the same sign. So that means I can add and keep the same sign. So -5 plus -7, I can just do 5 plus 7 is 12 and keep that negative sign. So my answer will be -12. Some of you would have been able to get that answer without rewriting it, and that is okay too. All right, here's our next one, 4 minus -5. So I'm gonna apply the same process. I'll add the opposite of the second number. So 4 minus -5, I will rewrite it as 4. Instead of minus, I'll write plus. Instead of -5, I'll write +5. So now look how much easier that is. It just turns into 4 plus 5, which is 9. I don't need to tell you any rules about why 4 plus 5 is 9. That one you should know. But here's what happened. When we subtracted a negative, those two signs next to each other kind of just turn into a big plus. That's what I learned when I was a student. I just made it into a big fat plus sign like this, plus. So when you're subtracting a negative, what you're really doing is adding a positive. Okay, so that's just another version of adding the opposite. So 4 minus -5 became 4 plus 5, which is 9. All right, let's apply this with some fractions. The next one is 1/2 minus 5/6. Couple things, I am gonna need a common denominator. Let's just use 6 as a common denominator. So LCD is equal to 6. So for the 1/2, I'm multiplying by 3 over 3, because 2 times 3 is 6. So I'll rewrite it as 3/6. So 3/6 minus 5/6. Okay, now I'll do the adding the opposite process, right? So I'll keep, change, change. So keep the 3/6, change the minus sign to a plus sign, and then the 5/6 becomes -5/6. Now for this one, I don't know if that really feels like it's any easier by rewriting it like that. I almost prefer it written as just 3/6 minus 5/6. But either way is fine. At some point you need to realize that the 5 is negative while the 3 is positive. So these numbers have different signs. So different signs, which means we're going to be subtracting and keeping the sign of the bigger number. So if I subtract, 5 minus 3 is 2, but the bigger number is negative, so it's actually going to be negative 2. So putting it all together, 3 6 plus negative 5 6 is going to be negative 2 sixths. Okay, but then I can reduce. So I'll end this one by dividing by a common factor of 2. And my final answer will be negative 1 over 3, or negative 1/3. Okay, lots going on there. So we learned about fractions, but they're not going away. We're still using all those rules with fractions. It's just that now we also have rules with negatives to add on to that. So just to recap what we did with that one, 1/2 minus 5 6, we got a common denominator of 6. So the 1/2 became 3 6. 3 6 minus 5 6, we rewrote that, keep, change, change. So 3 6 plus negative 5 6. Then we subtracted, 5 minus 3 is 2 for the numerator. We kept the sign of the bigger number, which is negative. So negative 2 6. And finally, we reduced by dividing by a common factor of 2. And our final answer is negative 1/3. All right, very good. So one more problem on this slide here. So negative 5/12 minus negative 3/8. Okay, we will need a common denominator for this one. And let's also make sure we are adding the opposite. All right, so which to do first? Let's, I think I'm gonna rewrite it first with the signs, then we'll deal with the common denominator. So that's a little different from how I did the previous one. So negative 5/12 minus negative 3/8. I'm going to just immediately recognize that when we subtract negative 3/8, that will turn into a big plus sign like we did in a previous problem. So when I rewrite it, negative 5/12, instead of minus, I'll write plus. Instead of negative 3/8, I'll write positive 3/8. So the original problem was negative 5/12 minus negative 3/8. Now it's negative 5/12 plus positive 3/8. So now let's talk about a common denominator. All right, so I like to think about common denominators in terms of multiples. So I'm thinking about what number is a multiple of 12 that's also a multiple of 8. So if 12 could work, that would be great, but it doesn't. 12 is not a multiple of 8. I'm going to make a short list here of multiples of 12. 12 is the first one. 12 times 2 would be 24. And that's actually going to work because if I make a list of multiples of 8, 8, 16, 24, there we go. So 24 is the least common multiple of 12 and 8. So I can use that as the common denominator, the LCD. So let's rewrite the problem having a common denominator of 24. All right, so I'm rewriting the fractions with a denominator of 24. 12 times 2 is 24. So I'm multiplying by 2 over 2. The numerator, negative 5 times 2, will be negative 10. And now for the second fraction, 3/8. 8 times 3 is 24, so I will do 8 times 3 and then 3 times 3. In other words, I'm multiplying by 3 over 3, which is a form of 1. This now becomes 9/24. So here's where we are. I've rewritten it as negative 10/24 plus 9/24. Now that we have a common denominator, we're ready to add, except it's going to feel more like subtracting because these signs are different. So I will subtract and keep the sign of the bigger number. So this time the bigger number is 10, and that one is negative because it's negative 10 plus 9 for the numerator. 10 minus 9 is 1. So I'll put 1 in the numerator. But again, we're keeping that sign of the bigger number. So my final answer is negative 1 over 24. Once again, you can put the negative in the numerator with the 1, or you can put it off to the side. So you can write it as negative and then 1 over 24. All right, so those are the examples I have for lesson 4 on adding and subtracting. You can see we're still dealing with a lot with fractions, and now we have rules with signed numbers to also keep track of. So if this was a normal class time, we would take a little break, and then we would go over lesson 5 as well. So I will end the video, but take a break, and I would recommend that you, as soon as you're able to, come right back and watch that lesson 5 video next. And it will use the same PowerPoint. So we'll pretty much pick up where we left off. All right, very good.